So if you wanted the degrees to go away, the units of degrees to go away, you would need to multiply by something that has degrees in the denominator so that they cancel. That's the way it works. It's built to work that way. So if I wanted to convert 30 degrees to radians, I would have to multiply by this guy. It's pi radians over 180 degrees. Just for the time being, I'm going to go ahead and write in radians. Although when you don't see it, you know that when you don't see the units of angle measure, you know it's in radians. Okay, when you don't see the little circle for degrees, you know it's in radians. So it's just assumed, yeah.
Oh, I was just thinking, we don't have to put our calculator in radian mode, right?
Not for this, no. In fact, for this one, we probably don't even need a calculator. So notice how the units cancel. Units cancel just like numbers do. They divide out just like numbers do. So you have 30 degrees in the numerator. The degrees here cancels with the degrees here, and you're left with units of radians. And then you would just multiply straight across and simplify as usual. So if you multiply straight across, you get 30 pi. Remember, you multiply fractions straight across over 180, and you should reduce that fraction. Okay, I think 30 will go into 180, right? So 30 goes into the numerator. If you divide the numerator by 30, you're just left with pi. If you divide 30 into the denominator, what do you get? 6. 30 goes into 180 6 times. All I'm doing is reducing the fraction, you guys. 30 over 180. And yeah, if you divide the numerator and denominator by 30, you will get pi over 6. So this is in radians. Again, we don't normally write it down if it's in radians, but for now, I'll write it down just so we're clear. So what did we just discover? 30 degrees is equal to pi over 6 radians. And you'll have that memorized actually pretty quickly because 30 degrees is one of those special angles. And you won't try to memorize it. It'll just happen. But now we don't have all special angles. We can approximate. So let's say we want to convert 27 degrees. Get your calculators out for me. Suppose we want to convert 27 degrees to radians. It's the same process. You start in degrees. You're going to multiply by pi over 180 degrees to get the degrees to cancel. So 27, so it's really just like the problem up above, times pi over 180. Okay, you can see that you've picked the right conversion factor. Pi over 180, you're really just multiplying by 1 when you multiply by pi over 180, aren't you? So does that change the value? No, it's just going to change the units. It's not going to change the intrinsic value of the measure. Okay, and then when you multiply straight across, what do you actually get before you simplify it? 27 pi over 180, yeah, the degrees cancel. You can think of it as 27 over 1 if it helps and multiply straight across. So you get 27 pi over 180. If you wanted an exact answer, you would simplify this. You would reduce the fraction just like in the last problem. So if you're told to find the exact answer, let's reduce it. What's the biggest number that goes into both 180 and 27? Is it 9? What would we get if we divide the numerator by 9? So we'd have 3 pi left. And then what if we divide the denominator by 9? 20. So 3 pi over 20. So 27 degrees is equal to 3 pi over 20 radians. Notice I didn't write down the radian measure because when you don't see degrees, you know you're in radians automatically. Okay? Now, what if you wanted an approximation to that? Just run it through your calculator. So this is an exact answer. In terms of pi, it's going to be exact. We didn't do any rounding off. When you plug it in your calculator, you're going to do some rounding off. So can you do that for me? Just take 3 in your calculator, 3 times pi. Locate the pi button on your calculator. So go 3 times pi and then just divide by 20. What do you get? 0.47. That sounds reasonable. So to two places. Is that rounded using the standard rounding convention? Okay, that sounds reasonable. Because I know 3 pi is really 9 point something, right? Which is almost almost half of 20. So that sounds reasonable. Okay, so that's approximate. So you should be good with an exact angle measure and approximate angle measure. Know the difference between the two. Okay? All right, let's move on. Let's go the other way. Here, I'm given 4 pi over 3. I know it's in radians because I don't see a degree symbol. Okay, so if it helps at first, write down 4 pi over 3 radians. Just to remind yourself that you're in radians. So which one of these conversions factors should you multiply by to get the radians to go away and degrees to appear? Yeah, you want degrees up top, so it's got to be 180 over pi. Pi radians. If it's not clear, it's pi radians. Okay, in the denominator. So 180 over pi. So we're going to multiply 4 pi thirds radians times 180 degrees over pi radians. And again, normally I don't show the radians here. You just, there's nothing, you know, if you don't show it though, there's nothing to do. So at least for this introductory example, I'm going to show you what happens. The units cancel just like numbers do. This radians, you can consider this as being in the numerator, and divide radians by radians, you get 1. Okay, so you're left with units of degrees. Radian, so you're in, degree measure. Now, can we cross cancel here, cross divide? I see a pi up top over here, a pi down here. The pi's divide out, right? And then you can always divide before you multiply. So you could take 3 into 180 and then multiply by 4, couldn't you? How many times does 3 go into 180? 60 times. And then multiply straight. There's 1 left down here, 1 left down here. So in the denominator, you're going to have 1 times 1, or just 1. And then in the numerator, you're going to have 4 times 60 degrees. What would that be? 240. Don't forget the degrees symbol. So multiply straight across, get 240 degrees.